Conceptual estimation is a higher level thinking skill that involves students in decisions that they need opportunities to think about and discuss. So, besides knowing how to reach exact solutions to a problem, everyone needs to know how to solve numeric situations that they need to know about answers. Many students confuse the idea of estimating with guessing. None of the three types of estimations involve guessing. Each involves reasoning and making sense. Computational estimation involves actual computing. Therefore, it is important to avoid using words like guess or guessing when working on estimation activities. When teaching estimation, discuss real-life situations in which computational estimations are used. Make sure you use words or phrases such as about, close, just about, a little more or less than, and between. Situations play a role in estimation. For example, it is important to know whether the cost of a car would be $950 or $9,500. Estimations can have different answers. The answer is that any particular estimate depends on the strategy used and the kind of adjustments made in the numbers. Estimates also vary with the need for the estimate. When teaching estimation, do not reward or overemphasize the estimate that is the closest. Instead, focus on whether the answer given are reasonable for the situation or the problem. The front-end approach is reasonable for addition or subtraction when all or most of the numbers have the same number or digits. Notice that when a number has fewer digits than the rest, the number may be ignored initially. Also note that only the front leftmost number is used and the computation is done as if there were zeros in the other positions. After adding or subtracting the front digits, an adjustment is made to correct for the digits and or numbers that were ignored. Over-under activity on page 266 and figure 1125 on 267. In this case, each answer is over or under $1.50. But the over-under number can be changed for each task. You can add an interesting context to make this activity more accessible to more learners. Consider playing the over-under game by picking one context. For example, the price of a candy bar or fruit and then varying the values. Say 5 at 43 cents each, then 6 at 37 cents each. And then asking the students, is this going to be about $1.50 over or $1.50 under? Students are not required to use rounding until about the 3rd grade, when they are expected to assess the reasonableness of an answer using mental computation. 3rd and 4th graders use place value understanding to round whole numbers. When several numbers are to be added, it is useful as a good idea to round them to the same place value. If it's going to round it to the tens, the hundreds, or thousands. Keep running a sum as you round each number. It is useful to look for 2 or 3 compatible numbers that can be grouped to equal benchmark values, such as 10, 100, or 50. If numbers in this list can be adjusted slightly to equal these amounts, that will make finding an estimate easier. For number 1, you can have students show the base 10 materials the value of these 2 numbers on placemats. Number 1 here, you can ask students to check their answers for reasonableness. If we start with 63 items and add more, we can end up with only 16 items. Number 2, again, it is back to 2 key pieces. Estimating the answer before calculating to see what his reasonable answer might be, and returning to the act of the situation with the base 10 materials. Number 3, start with a reminder about subtracting from 0 or other smaller numbers. Show 3 cubes in your hand and ask, can you take away 5? Number 4, have students use estimation to check for reasonableness of an answer. Number 5, have students use concrete materials to represent the quantities and solve the original addition problem. Number 6. When students are asked to find estimation, avoid having them check their estimates by finding the exact answer.